Hello, everyone. A very warm welcome to all of you. Welcome to the undergraduate webinar series, an interactive online platform connecting high school students to the Ashoka community. In this series, we cover topics related to Ashoka's undergraduate program, where our academic counselors, students, and faculty guide you in understanding the various aspects of the university. Thank you for joining us today for the webinar, Why Study Sciences at Ashoka. I, Jeena Shah, an assistant director at Outreach. I'm going to walk you through the entire presentation today. I come from a background of psychology and have very closely seen the Indian education fabric evolve in the edtech and the higher education space. I've worked with students and parents for over a decade, guiding them to make informed career decisions. Joining me today are two most distinguished Ashoka faculties, Professor L.S. Shashidhara and Professor Sheesh Banerjee. Professor L.S. Shashidhara is the Dean of Research and Professor of Biology at Ashoka University with specialization in genetics, molecular biology, and evolutionary biology. Professor Shashidhara has served in the past as the Vice President of the Indian National Science Academy and Secretary General of the International Union of Biological Sciences. He's currently the president of IUBS, first Indian to be elected in its 100 years of glorious history. He has represented India in the several delegations and in platforms. He's steering an international project on climate change education. For his contribution to the basic and applied biology, Professor Shashidhara is recognized with CSIR Technology and SS Bhatnagar Prizes and J.C. Bose National Research Fellowship. He's a fellow of Indian National Science Academy, National Academy of Sciences India, and the Indian Academy of Sciences. Professor Shashidhara holds a PhD from the University of Cambridge, UK. A very warm welcome to you, Professor Shashidhara.
Thank you very much.
Yeah. Our second speaker is Professor Sheesh Banerjee. He's a head of department and professor of computer science at Ashoka University. His primary areas of research are computer vision and machine learning, with a special emphasis on geometric algorithms. Recently, he has developed an interest in policy issues, digitization, and society, including digital identity, electronic voting data, and privacy protection, and fairness and reliability of machine learning algorithms. He's also worked extensively on the design of computing and networking infrastructure and IT services, and developed the supercomputing infrastructure at IIT Delhi, where he was a professor in the Department of Computer Science and Engineering. He has been an academic visitor of Oxford University, Indian Institute of Sciences, University of Illinois, Hebrew University, Microsoft Research, among several others. Professor Sheesh graduated in electrical engineering from Jawadhpur University in 1982 and did his master's and PhD from the Indian Institutes of Science in 84 and 89, respectively. A very warm welcome to you, Professor Banerjee. Without further ado, let's get started. Before we begin, I would request our audience to kindly type any questions that you might have in the Q&A box provided on your Zoom screens, and we'll address them towards the end of the session. With this, let me share a short presentation with you where we've set the little introduction on what is Ashoka and liberal education before I actually give it to our eminent professors today. I'm just going to share my screen and I'll put it in a slideshow so it's seamless for us. Okay. So talking about Ashoka University is the largest collective philanthropic initiative in the higher education space. The university was founded in 2014 and is located in Sonipat. The decision to found the institute was both inspired by the industry demands and the desire to change the mindsets of the Indian students and parents to see education as an end in itself rather than merely a stepping stone to securing a job. Talking about liberal education. So what is liberal education? Liberal education gives you the freedom to choose what you want to study, thus challenging the silo wings of disciplines in the current Indian education system. You get to choose from disciplines across natural sciences, social sciences, and humanities. With the interdisciplinary approach, liberal education focuses on taking you to the breadth and the depth of disciplines. One of the research published in the Wall Street Journal mentioned that each of us would change 7 careers in our lifetime. And mind you, it says careers and not jobs, which means that some of you students might actually work in companies that have not been founded today, or you might just work in industry that doesn't exist today. In that case, what do you prepare yourself for? You have to prepare yourself for transferable skills. You need to be able to be a good communicator and to be able to write well with a spirit of public service and leadership skills. Ashoka University offers a full-time residential multidisciplinary program in liberal education, a UGC recognized 3-year degree with 9 foundation courses which are mandatory for students and a broad spectrum of disciplines to choose as your majors and minors. Just a quick glance of what are the different options of majors and minors that you can explore from. So you have to choose one pure major, which would be from the pure majors list. We have a list of interdisciplinary majors and a minors as well. Co-curriculars is also mandatory at Ashoka. Looking straight into what are the sciences at Ashoka. So you have your entire range of pure sciences, which is your physics, biology, chemistry, mathematics, and computer science. Also, we have an interdisciplinary major, which is the computer science and entrepreneurship, and computer science and mathematics. Talking about what are the unique features of sciences at Ashoka. So one, you're studying a unique liberal education pedagogy. And often I'm asked with students saying that, do you get a degree in liberal education? No, it's a pedagogy. It's a methodology of how you've taught. We're talking about interdisciplinary courses here. And that's very important here, where we say chemistry needed to understand modern biology and should be taught as chemistry for biology rather than chemistry for chemistry. Biophysics with physics, we're also looking at life in the neighborhood with environmental sciences, computational biology with bioinformatics with computer sciences, ecology and evolution. Our faculty come trained from all over the world and are best in the field, with expertise in areas that are not represented in India. They innovate in teaching. They do experimental, computational, mathematical, theoretical research. You as a student can also work with them on research, and we have students who co-authored papers while pursuing their undergrad program at Ashoka. Ashoka Science faculty includes 6 SS Bhatnagar awardees, highest prize that you can get in sciences in India, and one of them is with us today, Professor Shashidhara. We're also looking at industry-oriented teaching and curriculum with cutting-edge research, a close intersection of experiments and theoretical work. Our students implement in the lab what they actually study in classrooms. We also bring in focus on societal and real-life problems, environment for the future, affordable drugs, renewable energy, biofuels, climate change, and these are the real-life problems that actually need attention today. With that, I'm just going to stop share here, and Professor Shashidhara, over to you. I would want you to share your thoughts and also talk on the today's topic, which is why study sciences at Ashoka. Professor Shashidhara?
Hi. Thanks, Gina. You really made a wonderful presentation. It's made our job much easier now. So, dear students, good evening, and I'm sure you're all staying safe, and hope you have understood what the SARS-CoV-2 is all about, how it causes the disease, why COVID-19 is a pandemic, and why so many other viral diseases which you have seen in the last few years are so-called epidemics, and why something is called pandemic. I think that kind of understanding requires interdisciplinarity. Not only you need to know biology, you also need to know data science, you need to know social science, you need to know public health system and biomedical aspect of the disease. So to understand the just enormity of this disease, forget about how to treat, how to get vaccine, how to supply vaccine to the masses, what is the supply chain pipeline for vaccine supply and other things. just to get an idea about what makes a disease to explode, like to become a pandemic, you need an interdisciplinary understanding. And Ashoka is the forefront of this kind of an interdisciplinary training of undergraduate students. In fact, when talking about pandemic, some of the Ashoka faculty are always in the news because they are the ones who are consulted by the government, by the public health officials, as well as by the media, to take inputs about how to understand the pandemic and how to deal with the pandemic. People like Professor Sheesh Banerjee, who is here, Dr. Shahid Jamil, Professor Gautam Menon, and they're always being consulted by various different platforms to understand as well as find solution to the pandemic. So let me share my slides, and I'll sort of quickly go through some of the maybe repetition of what you just heard. First, the question you can ask yourself is, why Ashoka University, right? The second question is, why science in Ashoka University? Why Ashoka University? Because it's a liberal arts research university. There are two reasons. One is liberal arts university and liberal arts research university. When it say liberal arts, it is not arts and science kind of a difference that you always think. It's an American term, liberal arts. It started in the first half of 20th century, because when science was becoming more and more prominent in the society, people are becoming too sort of discipline oriented: physics, chemistry, biology, mathematics, and so forth. But to understand the society, remember the 20th century big first half is also a time when the world went through two major world wars, First World War and Second World War. So they thought the undergraduate level students should have an open mind. They have a liberal mind, and should have the art of learning things on their own, and they should develop interdisciplinarity. And to provide that kind of a platform, these so-called liberal arts colleges, liberal arts university, liberal arts curriculum were developed. Some of the major Nobel laureates are started in liberal arts. For example, Michael Bishop, who won Nobel Prize for discovery of one of the genes which is basically driving the cancer, is a biomedical researcher. His undergraduate degree major was English literature. He wanted to do PhD on Wordsworth. And then later, he decided that he will pursue biology and biomedical research, and went on to, sort of win Nobel Prize for the fantastic work that he did. That's what liberal arts is all about. When you say research university, is where undergraduate teaching is integrated with research. And to do research, obviously, you need researchers. And to teach also, the same researchers come, then where you integrate undergraduate teaching and research. The second point is, undergraduate students themselves learn by doing research. It's not simply listening to researcher in the classroom. You actually learn by doing research. This is the total integration of research and teaching. And that's precisely how you learn, for example, engineering subjects in the IITs. Or, if you go to any of the foreign universities, like in Europe or, in America, not all American universities are research universities. Only the top universities are research universities. And this is what Ashoka aim to do, to provide you undergraduate education in a research ambience, in a very research integrated way. And this has already been talked about, because you need research faculty, and they should have a very good training in doing research. They should be doing fantastic research, and they should also be able to teach undergraduate students in addition to train PhD students. And that combination is very important. And because they have a more deeper conceptual understanding of the subject, because they do research, it's easier for them to teach. I'm sure you all have heard from great scientists keep saying that if you have understood well, you should be able to teach a 6th grade kid the science. If you cannot teach a 6th grade science student the scientific concept, that means you are not understood this. You do research, right? For example, I mentioned here, if I want to understand the chemistry of biology, right? A chemist, when they teach the chemistry of biology, they should know what is the importance of chemistry in biology, rather than simply talking about the atomic interaction in chemical molecules, right? But that becomes pure chemistry. But the same chemistry scientist, when they try to address chemistry to biology students, they change the way they teach, because they provide better conceptual understanding of the subject. That's the kind of faculty we have in Ashoka. And also, when we provide scientific understanding, the foundational knowledge, will ensure that you learn science the way the natural world functions. There are certain laws of physics which basically govern all aspect of the natural world, both at the atomic scale as well as at the galactic scale. That is the same thing which also dictates the chemistry, that also dictates the biology. Just because we biologists look very different, we are not very different from a physical world. The same atomic laws of physics, or the same quantum physics, or same laws of motion would impact the biological entities too. But built on the physics of that, there are certain chemical properties that emerge because of the chemical interactions of the molecules, which are more complex than atoms. And then the biological properties emerge when large molecules, chemical molecules like DNA and protein, interact with each other, because they are even larger and they are more complex. So as you can see here, the complexity emerges because of interaction of larger molecules. It's not because they're very different than physics or chemistry. They follow the same laws of physics and chemistry, but it's simply a different scale of complexity we need to study. That's how the nature has, these materials have evolved in the nature, or emerged in the nature. And that's how we're going to teach you also. The way nature functions, that's how you learn in your classroom as well as in the laboratories. These are some of our, great faculty we have. Again, in kind of research our faculty do, for example, in biology, it's going to be a lot of work on disease biology or cancer biology or synthetic biology, which is one of the modern areas, or including fundamentals of biology without deviating from genetics, evolution, molecular biology, biochemistry. You will get a comprehensive understanding of biology in an interdisciplinary way, because biology is finally a combination of physics, chemistry, data science, and mathematics. You cannot do good biology without having those trainings. Not necessarily that you come prepared with some physics or chemistry or biology or mathematics understanding. That's our job. You have to have interest to learn biology in its core sense. And our job is to teach the interdisciplinary aspect of the biology. So in physics of biological system or complex system physics, or condensed matter physics, soft content matter physics, they are the kind of areas which basically deals the complex aspect, complexity in the system. And of course, at the same time, the deeper understanding of physics, where there is still the big knowledge gap, is in the quantum field theory. That's where our faculty are focusing on in their research, and the same thing they teach. We have just introduced a new program in astrophysics. One of the celebrated astrophysicists is joining us very soon in the coming semester. Chemistry, I'm sure chemistry is more applied, in addition to being very fundamental, trying to understand the atomic interaction at the molecular level. So, for example, the application of chemistry in biology or in environment or in pharmaceutical is something which we are going to focus on. And I'll skip this. This is what the chemistry is all about. Computer science, Professor Sheesh Banerjee is already here. We have some really good computer science faculty, both in computer system, in structure, infrastructure, as well as the software and the very different applications, and also in the core computer science area. And some of the faculty are really celebrated in their field and well known both in industry and academia, both nationally and internationally. One of our visiting professors in computer science is Professor Ramesh Jain. He just gave a lecture last week, and he's going to continue to give more lectures. And he's considered as the father of computer applications for societal good, whether in health or in any other social problems of the society. And Ashoka has understanding with very different top institutes, both in India and outside. These are just the examples, some 4 or 5, where our undergraduate students and PhD students can do internship or go and some work in those places, assuming that when you can able to travel and go to different places. And thankfully, hope with post-vaccination, all that may happen from January 22 onwards. And we also starting up some new programs. Many of the programs is starting in 2022 January onwards, so-called post-pandemic period. For example, this is already undergoing with the Professor Sheesh Banerjee will mention. It's already started, because in data science, you can still do online. We don't have to be on campus. And we're just starting a multi-scale computational biology program. It's going to be really a center of excellence on computational biology. And we also have started a university-wide transdisciplinary initiative on climate change and sustainability, which is something which all of you need to learn, irrespective of which profession, which career path you take. The future of the world, you cannot survive without some scientific understanding of climate change and sustainability. And all our, the entire life will be around, dealing with this problem in future. And Ashoka students will get full exposure to these kind of issues. We also started an exciting new program to bring in the modern science with archaeology to understand the past history of Indian civilization. We're also moving to a new campus with more buildings added, and hopefully it will be ready in 2 years' time. This is the kind of new building coming up. This is not simply an artistic view, it's actually an architectural drawing. I'll stop here. Thank you very much.
Thank you, Professor, for giving us that in-depth understanding on how sciences can be different and what are the kind of depths that we can achieve at Ashoka. With that, Professor Shubhashish Banerjee, over to you.
Thank you. After that presentation, I feel like becoming an undergraduate myself. So let me share my slides. Oh no, full screen, right. So my slides are a little colorless compared to Jinal's and Shashi's, but that is not to say that computer science is without color, right? So I'll talk about computer science, and Shashi has given a very good introduction to science in general. So before I come to why computer science at Ashoka, let me spend some time on what is computer science about, right? So, and first thing that we need to understand it is what it is not about. And computer science is not about just coding. So programming and coding, they are crucial aspects of computer science, but they're not just the only aspects of computer science. So apart from coding and building systems and writing large programs and fun programs, as a part of computer science education, you will learn many other things, right? And what are they? Fundamentally, at its core, computer science is about design and analysis of algorithms and methods of computation, and they range from a wide variety. So it is probably the oldest subject that is known to academics. It's a subject that has probably existed for more than 10,000 years. So, at least as long when people started counting and numbers with their fingers, right? They used algorithms. They used procedures to count. And the earliest counting goes back to civilizations like the Egyptian and the Babylonian and the number theory. Julius Caesar tried cryptography first, using some algorithmic procedure, using something called a substitution cipher, versions of which continue even today. So when you talk about routing can be about, say, routing a bus through a city, or routing an internet packet. So as I speak, the voice and the sound bits from me to you through a variety of routers sitting across the geography, they are all algorithmic problems, right? So if I have to schedule aircrafts, so if a large airline like Air India has to figure out how to schedule aircraft so that they can maximize people travel and minimize wastage, that's an algorithmic problem, right? That's an optimization problem. Games, I don't have to tell you about games, but games extend to simulators. So when you teach somebody how to drive or how to fly a plane, or even a surgeon to do pre-surgical planning using a virtual reality simulator, those are computer science design problems. Right? So they are modeling problems, they're design problems, and programming problems, of course. Graphics and vision, you've seen movies, you've seen Hollywood movies, you've seen special effects, Matrix, Harry Potter. So they are all again fantastic computer algorithms. Networks. So Shashi mentioned COVID. There are a large number of people at Ashoka University involved in studying networks of human beings and how diseases spread from one human being to another. And these are not static networks; these are dynamic networks of people about spread of infectious disease, and that's a branch of subject called epidemiology. And most of the models that have come about are computer science models. So computer science talks about biological communication. So how a messenger RNA leads to protein synthesis, or how polypeptide chains fold to make biologically sensible proteins in 3D. So these are all problems that are computing based and algorithmic. And now the paradigm has even shifted. So now you're saying that data and machine learning, so even without specifying algorithm, the subject of data science and machine learning is talking about that how do you synthesize algorithms out of the data? How you find hidden correlations in the data to discover new knowledge, right? And all this is computer science. It's also about processes and protocol. So for example, if Jinal is designing a system to select you into Ashoka, and if she has designed a process, the way a computer science scientist would look at it is to ask the question that, does her process, is it possible that her process exclude somebody who is deserving, or does he end up selecting all deserving people? So these are questions of completeness and soundness, and that's the way a computer scientist will model all processes. And computer science is also about designing computer system. And as Richard Feynman, a great physicist, hypothesized, that Mother Nature is computing. All that Mother Nature is ever doing is computing through molecules, computing through atoms. And understanding Mother Nature is to be able to simulate her functions, right? And so to do that, we have to understand limits of computation. So when you study CS, you get introduced to this entire magnificent subject. And why CS at Ashoka? Ashoka teaches you all this through a multidisciplinary study. So you can study CS plus X, right? So broadly, I am not getting into taxonomies of major, minors, and concentration, but essentially you can study CS in conjunction with any one of these things, right? Biology, physics, or chemistry, even mathematics. So you get a double major in CS and mathematics. That's possible. If that's your interest, you can do a minor in CS and you can do a major in CS and a minor in economics, or you can do a major in economics and a minor in CS, right? And in the coming years, I envisage that the major applications of computer science will happen in the areas of economics, political science, sociology, how to do election campaign, how to win elections, and so on and so forth. Also to understand the brain, how the brain functions, through psychology, linguistics, or computer science. And in Ashoka, you will learn all this through undergraduate research. So this is, as Shashi has mentioned, this is a research-heavy course. So the pedagogy of teaching will be research-heavy, and Ashoka will provide you the opportunities. What are some of the take-homes from this? As a student, the opportunities are enormous. You can go for graduate studies. Several of Ashoka students have gone to top universities in India and the world for graduate studies, for postgraduate or PhD even. There are incredible internship opportunities with companies such as Google, Microsoft, and you name it. And of course, nobody starves after computer science. They are good jobs, so let's not, so you can expect a very, very comfortable and an engaging life after studying computer science. So I think I'll stop here, and rest of it, Shashi and I can take in questions. I'll stop sharing.
Yeah. Thank you, Professor Banerjee, for that insight. And while you were talking about data, I just remember having watched this documentary on Netflix, The Great Hack, where they're talking about how data analytics has influenced the 2016 US elections. And it's all about data, truly. Okay.
Well, in India also we are trying, right? The famous,
absolutely.
what is his name? Prashant Kishore.
Prashant Kishore. Right.
Yeah, he's so famous. He's a data analyst, a data scientist.
Yeah, he's winning all elections. Whichever party he goes for wins the election. Yes.
Absolutely, yes.
So computer science, yeah.
True. So let's just look at a few questions that we have from the audience here, and I'm just going to look at.
And also, there is a hand raised, but one student has raised the hand.
Okay, we'll also address that as well. Sure. Okay, the questions that are coming to us. So can we pursue a double minor in biology and chemistry at Ashoka University? Would you want to take that, sir?
Yeah. So you need to have one degree at least. So somewhere you have to have a major. You can have double major, and or you can have one major, one minor. To having two minors, it's not going to sort of get you a degree because there is no. We want to introduce what is called as interdisciplinary science degree, where there is no major minor. So you learn a bit of everything and sort of become some kind of a master of multiple disciplines. But that will happen at some point later when we fully introduce a 4-year degree course. Right now, you have to have at least one major and one minor. You can opt for it.
Yeah.
Or two majors. Or double majors is possible.
Yeah.
Yeah. Also, if you take up the 4th year at Ashoka, you can convert your minor into a major, which means then you have a double majors. Yes. And with the new NEP, I think we will soon have a 4-year program. Definitely. Okay. Let's look at another question that we have. That can you give an example of what chemistry for modern biology means? So, Professor, we just talked about how chemistry has to intersect with modern biology, and I think the students are very interested to know what are these intersections that we're talking about. Yeah.
So, very simple. For example, in the RNA virus, for example, RNA vaccine. Many of you must have heard about Moderna vaccine in US, which is already introduced, and India is developing in two different pharma industries. One is Genova in Pune, another is Zydus Cadila in Ahmedabad. Zydus has two vaccines. One of them is an RNA vaccine. RNA as a molecule, it's simply a polymer of nucleotides, like a DNA, polymer of nucleotide. It's simply a chemical molecule. Now, how RNA can be used as a vaccine, how it enters, how once you inject, how it enters the cells and body, you need to look at the chemical interaction between RNA and other constituents of the cell, right? It doesn't have any other kind of biological properties that you ascribe to move around on its own, right? And because of this, you need to have a better understanding of the chemistry of that particular piece of RNA molecule which is being introduced. And what are the chemical reactions inside the cell once an RNA enters? Because it happens inside the cell, we call it as biochemical reaction, but in reality, it's simply a chemical reaction.
Yeah.
So that's what we meant by chemistry of biological systems.
Yeah.
So just one example. There are multiple examples. Another is what's called chemical ecology. For example, there are many nocturnal insects, bees, and moths. They go to the flowers for nectar. How do they know which flower to go? Right? Because they smell. Thus, the flower, the aroma that's coming out of the flower, not because they see a nice colorful flower, because in the night they cannot see that. And the way they can identify the right flower to go for the nectar is because there are certain kinds of chemicals, and those are all small molecules which are emitted by the volatile. They're volatile, so they are emitted by the flowers, and they are received at a single molecule resolution from a far distance. A moth can recognize, and that interaction is a chemical interaction. When a single volatile molecule hits the antenna of the insect, there are some chemical reactions happen. That chemical reaction, if you understand, you will get a better understanding of how the insect and plants interact. That's also chemistry of biological system, very complex biological system.
Sure. That just tells us that I think it's only in books and syllabus that these subjects are different, but in the real world, I think there is no distinction of these, subjects there.
Exactly.
Yeah, the problems don't know whether to go to a biologist or a chemist.
Absolutely, so true, so true. With that said, I have a question for you, Professor Shubhashish. Students are asking us, saying, how is computer science different from engineering? Or how is computer science at Ashoka different from an engineering college? And since you've been at an engineering college and now you're at Ashoka, I think you will be able to best answer this. We also have a subsequent question attached to this, which says, what are the placement opportunities after completing CS? And you said very clearly that nobody's going to starve after having done CS. But if you could just give a little more details of what are the kind of roles and what are the kind of companies that students can look at.
Okay, so the first, let me take the first question, right?
Yeah.
So computer science and engineering intersect when you try to build computer systems, right? So you try to build this Mac that I'm using right now, like the Apple Corporation tries to build a Mac right now. So they have to deal with a lot of things, how to dissipate the heat from this, how to make the battery life large, and so on and so forth. And that's a whole lot of questions that are engineering questions that comes up. What is the compiler? How do you design the compiler? How do you design this hardware? How do you do an Intel chip design, and so on and so forth. And Ashoka is not an engineering school, right? So while these aspects of engineering will be covered at a very broad level, at the level of physics, these will not get covered to the extent as they will in a place like an IIT, right? Like in IIT Delhi, where I've taught for 30 years. However, computer science as a subject was, as we know it to the modern computer science. As I said, computer science is probably 10,000 years old, but the computer is only 70, 80 years old. It's 1945 when von Neumann designed it to make the atom bomb. So, and in 45, from 1945 to 2021, you have gone through a massive set of engineering. So this has been a set of when computer science in these 70, 80 years looked inwards. And much of the effort was how to improve the computer system and how to make it work faster and so on and so forth. But I think that has saturated a little bit. And the next kind of questions that the computer science, as computer scientists will ask, will be the questions like the great computer scientists of the past years asked. Like when Gauss and Newton did computer science, most of the algorithms that we do today are amazingly designed by Gauss and Newton for machine learning. And when computer scientists, I think, will go back and ask questions similar to what Gauss and Newton asked: how to improve the society, how to win votes, how to do economics, how to do sociology, how to do cognition. So I think that the next few decades of computer science will again look outwards from the computer system to solve problems of society and problems of science. Okay? And I think that that will be less to do with engineering and more to do with society and more to do with science. And I think that Ashoka gives the advantage of integrating computer science with a whole lot of other subjects which are non-engineering. This is not to say that you can't do engineering. I mean, post Ashoka, you can of course learn engineering. You'll be more than well equipped to pick up computer engineering as well if you so choose. So yeah, that's the question. The second question that you asked me are what are the career options, right? Yeah, so I'm new to Ashoka. None of the students that I am teaching now have graduated. But I've seen and looked at what they do. And I think they've been all sorts. There have been a huge number of people who have gone on to study further. They've decided and opted to do graduate studies, master's and PhD. That's an incredible number. And to my mind, that's a very, very good sign. Right? They want to know more. And they have taken up jobs in top top computer science companies like Google and Microsoft and even Intel, which is an engineering company. I amazingly found that few people have taken up jobs at Intel. There have been entrepreneurship. Many have then joined, startups. So sometimes when you join a big company like IBM, you're a little lost. You're one in many. But when you join a startup, you're at the center of things, right? So, and I find that entrepreneurship is a very strong characteristic of Ashoka students. So many have joined entrepreneurship. There are some who are sticking around in Ashoka. They love it so much that they're not leaving. So, they are doing projects with the faculty member. So Ashoka has this fourth year option, right? The ASP option, which is what is it called? Advanced. So
Advanced Studies and Postgraduate
Studies program, ASP we call it.
ASP. So which essentially means that you can choose to spend the fourth year at Ashoka, do an additional fourth year at Ashoka, and learn more, do more courses, and move on. I find that in computer science, an overwhelming majority, I would say that almost 80% choose to do that. Choose to spend one extra year at Ashoka and do the ASP program, and some actually even stay beyond. Even though they have opportunities to move out, they stay beyond. They're doing all kinds of things. Some people are designing some software. Some people are helping professors design COVID models. So they're caught into exciting things. I think that all that matters is that you do exciting things and be happy about it. Yeah, and Ashoka provides that opportunity.
Absolutely, so true. Yes.
Gina, I was also going through these questions.
Yes.
There are some which require just one line answers, right? Shall I quickly?
Yeah. Sure, sir.
For example, why students not show interest in genetic concept? I think it's, maybe there's a misunderstanding of what genetic concepts are. It may be possible that she's referring to, or he's referring to Mendelian genetics. Without understanding Mendelian genetics, you can't understand modern genetics. Modern genetics is all about understanding DNA. So people wanting to know how DNA makes copies of itself, how DNA carries information from one generation to another generation is nothing but genetics. So in a way, people are interested in genetics. Nowadays, the DNA forensics, DNA-based forensics in one of the major applications, or DNA-based diagnostics, another major applications like what we are going through in the current viral diagnostics. All of them are basically understanding the genetic. Without understanding genetics, you can't do any of these things. Other option for statistics? Yes, of course, we do have a fantastic program in statistics along with mathematics. Some of the great statisticians are with us. The former head of Indian Institute of Statistics, he's a faculty in Ashoka. I showed his picture. Rajendra Bhatia, a very celebrated statistician and mathematician. Career in psychology and biology, yes, of course. Psychology initially was thought that it's only about understanding the behavior from when you look at from outside, and it is more useful for social psychology and marketing and such kind of things. But now we know that we can't understand the behavior unless we understand the brain. So a combination of understanding the human brain and it's a behavioral output, what you call a psychology, had to go hand in hand. Don't need to go deeper into the brain, but you need to have some understanding of the brain to understand psychology. So Ashoka's program in psychology includes cognitive neuroscience, which is nothing but the biology of the psychology. There's a great career opportunity nowadays in psychology coupled with cognitive neuroscience. Do I need to have opted for science in my 11th and 12th to be able to pursue science at Ashoka? Not necessarily. As long as you have some mathematics background, you can enter into physics. For biology, you don't need to have any prior, experience in exposure in mathematics or even in biology.
Actually, if I may add on here, what I really like about the Ashoka curriculum fundamentally, and I wish I had it at the foundational courses. So Ashoka first year, they have this set of foundational courses which spans across sociology, psychology, computer science, physics, chemistry, biology. And no matter what you do at Ashoka, these foundational courses are compulsory. And foundational courses, of course, give you foundational background. So even if you have not done science, you will get an adequate exposure to science through the foundational courses. And should you choose to change over to science, I think Ashoka is one of the few rare places in India that will give you that opportunity. So,
yeah, for the school kids, it's very important to know that the modern day understanding of sciences is not about remembering facts, figures, and definitions, because the information is available at the click of a button on your mobile phones. You don't need to remember anything. What you need to have a conceptual, foundational understanding. That's what Ashoka researchers will help you to gain. For example, if you don't need to know all the finer features of DNA, as long as you know how DNA maintains its integrity in the information fidelity, right? And what chemistry behind that information fidelity is more important than actually looking at all the finer details. That you can always refer to any textbook or internet source. There's one question about introducing philosophy of science. Yes, right now there are 2 courses on philosophy of science running. 200 students are, irrespective of which background or which discipline they want to pursue, they're all showing a lot of interest in philosophy of science. Subhashish, there's a question for you.
Philosophy of science
I have
is a
a
course
zero
that I would
knowledge
love
on computers or coding or computer science in 11th and 12th. Can I still take computer science in my undergraduate at Ashoka?
Yes, so this is not only in Ashoka, this is true even in IIT, right? So you can do computer science at IIT without ever having touched a computer. I would think that that's an advantage. Yeah, so you learn it the right way. And
also,
Okay.
we have one question, sir, where somebody's asked that, do you need a SAT score to take admission at Ashoka? You don't need a SAT score. It's optional. If you have one, you can put it one there. There's one more question. If I'm undecided, can I come to Ashoka and then decide on my majors? Absolutely, you can. The whole idea
That's the whole about liberal arts.
Yes, that's the whole idea of signing up for a liberal education program where you're allowed to explore. So you come in at Ashoka, you do your 9 foundation courses, you explore through the major minor options. At the end of your 3rd semester is where you declare your major and not before that. So you're absolutely allowed to come in undecided. Also, the way you look at subjects at Ashoka is very different from what you've studied at school. And I've come across so many students who said that I probably hated math or I probably didn't like this particular subject. And then I fell in love with it. And now I went ahead to pursue a major in that subject. So be very open to coming to Ashoka and then exploring and learning in a different way. Yep.
I think that, if I may add, being undecided is good. Being decided too early is not a good idea. I think that keeping your mind open. I'll tell you that I sometimes find myself undecided about what I want to research on next. So, yeah.
There are quite a few questions on double major. I think answer to all of them is yes, double major is possible. We encourage them, and double major can be across any combinations. It doesn't have to be 2 sciences. You can have double major between biology and performing arts, or computer science and performing arts, computer science and economics, already explained by Mr. Subhashish.
Yeah.
They're asking, how many of your associates are like IIT Delhi and other foreign institutes? So the question, if I interpret it correctly, is that while you're a student at Ashoka, can you do a project elsewhere, right? Yes, you can even do a project at Google, or at Microsoft, and all that is possible. And there are, we have agreements by which you can go out and do projects, in startups and large corporates, and in IIT Delhi. And there are several IIT Delhi and Ashoka students who are jointly doing projects with me. So not only can you work on it, you can make a team across institutes and work on projects.
Absolutely. And there is so much opportunity. One, summer semesters, you can do it with multiple partner universities. You can do a summers at Ashoka. You can do an internship. So it's not bounded. You decide your course. It's also upon, as a student, how much can you take on and how much more do you want to get into. You have your professors who are themselves into research. You want to, involve yourself in researches. You're allowed to do that as well. Absolutely. Yeah. Okay. We have I think we'll take one or two more questions before we wind up, sir. One question on physics, and this is around astrophysics. So do we cover astrophysics as a part of our curriculum? Yeah.
Yes. So astrophysics is already being taught as one of the courses, but it's not yet become a major program. Which, as I showed in one of my slides, we have a new chair in astrophysics program, a distinguished and a celebrated astrophysicist who worked on LIGO project. Is joining Ashoka from January. And then we'll have multiple courses in astrophysics. So within physics, someone can specialize in astrophysics if they want, but that happens usually when they do fourth year program in Ashoka. Because there's no time to specialize within a discipline, because you have to get a conceptual understanding of that discipline before you specialize in a subtopic of let's say in physics, quantum physics, or astrophysics. So 4-year degree program is useful for specialization within a discipline.
Okay. Yeah. And I think the last question we'll take in here. So is Ashoka is called a research university or a research-based curriculum is what we offer at Ashoka. And the student is asking that if I have to pursue my PhD, what is the route, if I am studying at Ashoka 3 years, and then can I directly get into PhD program?
So the answer is 3 years, no. I mean, I think that except some places in England, most places don't accept PhD, being taken to PhD from a third-year undergraduate program. But what most universities in the world, including Ashoka, will allow you to do is to join a master's cum PhD program. So you join a master's program and you'll have the option to exit with a master's degree if you so choose. Or after 2 years of master, you may say that, okay, I don't want the master's degree, I will continue to get a PhD. And that most universities in the world will allow you. In the United States, most universities will want a 4-year degree because the undergraduate in the United States is 4 years. So they will want you to have spent 4 years before they'll admit you to the master's program, right? But in Europe, after 3 years is possible, not directly to PhD, but in a joint master's PhD program.
So under NEP, hopefully the 4-year degree program will also start, and they may accept, all Indian organization also may accept our 4-year degree program as a prerequisite for PhD. Then they can directly go for PhD.
Okay. Yep. Okay. With that, I think, sir, we're just in time, and we'll end the question and answer section. And with that, thank you for joining us today for today's webinar. I hope by now you know why study sciences at Ashoka. Before we wrap up the session, we would really appreciate if you could just take a minute or so and just put in your valuable feedback with us. The link for the feedback form is provided in the chat box. Please note that the recording of this session is available on Ashoka's YouTube channel in case you would like to share it with your friends or family. Before we wrap up for today, I would like to inform our audience that round 1 admission for Ashoka's undergraduate program will open on 4th of October. You don't have to wait for your board marks to apply. You can actually apply in the round 1 right now. Join us for the next webinar on undergraduate admission process and application form to understand the Ashoka's holistic admission process and why you should apply in early round and what are the advantages. This webinar is scheduled on Friday, 8th of October from 6 to 7 p.m. and will be conducted by Moshia Prince, Director, Office Admissions at Ashoka University. The registration link for this is also provided in your chat box. We also have a series of other admission-related webinars coming up in the next few weeks where our team will help you clarify your doubts regarding the various aspects of the admission process and the undergraduate program at Ashoka University. So mark your calendars and stay tuned for more updates on that. If you have further queries regarding various other aspects of the university, feel free to write to us at apply@ashoka.edu.in or call us on the number which is mentioned on your screen right there. Once again, I thank both professors, Professor Sheesh and Professor Shashidhara, for taking out time to participate in this discussion with us. This brings us to the end of the session. Please take care, stay safe, and all the best for whatever you decide further with your career.
Thank you. Thank you.
Thank
all.
you. Thank you.
Thanks, Gina.